Okay. So you start with a scatter plot. So there's a data set called cars. I think it's in mass package. So let's quickly go to mass, take it so that we have access to cars data. So we start typing cars, and then we get the health files for cars. So it says speed and what? Stopping distances of cars. Okay. So the data give the speed of cars and the distances taken to stop. Remember that I said if I ask you to get a description of the data, you do question mark, and then you have that sort of description of the data over here for you to describe the data. Okay, so cars, the format is this. It's a data frame. We know what the data frame is, isn't it? It's rectangular. The columns will be what? Variables. The rows are what? Individuals. Okay. So it has two variables, speed and what? Dist. Dist is distance. Okay. So how do I get a scatter plot of this? I can just plot it like this, cars, because you can get a plot a data frame like that, which is distance and speed. I can also use X and Y. Is that okay? Yeah, so it depends on you. Yeah. So I could have also done it this way by saying that X is equal to cars. Because it's a data frame, then I choose speed, and then Y is equal to cars. I choose what? Speed, dist. I need to, well, the S lab is labeled correctly, but I can go in and put in even the units within which it is measured. That makes your graph well explained. I mean, if you are putting up a graph, you want it to be self-explanatory. In other words, you don't need to even talk about it. People will know what the data is about. So you provide as much information as possible, but you have to also make sure that it doesn't clutter the space. Okay. Right. So I can come here and check. The speed is in miles per hour. So I can use that as my S label, speed, into bracket what? MPH, so that the audience already know what speed. Because we can also measure speed in kilometers per hour and so forth. Okay. So let's do so. So S lab will be what? So we put all that into that speed, then we put what? MPH, right? Miles per hour, like this. Okay. Then what about the Y lab? Y lab will be what? Speed. Oh, sorry. Distance. It's actually breaking distance or stopping distance. So you write stopping distance, and that stopping distance is in what? In feet. So you put it like that. It makes it more interactive, right? Okay, so I can get my Palmer to make it to fill the entire. As you come. Should I? As you come. Okay. Okay, so run it and you should have something like that. This is more explanatory than the previous one, isn't it? Please, are you done? I told you that if you were really able to do it, I think that maybe should have been your friend. What can you say about the relationship between the stopping distance of a car and the speed at which the car is traveling? Yes. What happened? Yes. Yes. What can you say about the relationship between these two? What is positive relationship? What? Is what? What do you mean by the positive? As what? Yes. The stopping distance also increases. Okay. All right. So yeah, that's it. So if you are traveling at a higher speed, you need what? More distance to brake. Otherwise, you hit the car or an object in front of you. Is that okay? All right. Okay. So now I want you to do one more. I want you to check the relationship between the miles per, the relationship between the price of a car and the miles per gallon in city, in the Cars 93 data set. So please get a scatter plot on miles per gallon. Sorry, miles, is it miles per gallon? Yeah, MPG. Okay, so in this case, the price will be of interest to you. That will be the y-axis. You want to buy a car, but you want to check the consumption based on the consumption, right? So in the Cars 93 data set, you have miles per gallon. You also have what? Price of the car. So get a scatter plot of price of the car, of course, as the y-axis. Then the x-axis is what? The miles per gallon in city. Please do so. Label it nicely. 5 minutes. because I did plot cars, and now I say cars 93, so you also plot cars 93. You remind me of Saudi. He never solved the problem in class before. And when I was a student, I was always asking him, I said, bro, solve one for us so that you know how you want us to solve it. Because every assignment we do, the maximum you get is 5 over 10. 4 over 10, 5 over 10. He says, you want me to solve it so that whenever you go, you say, oh, so you solve it like this, so you solve it like this. I made a comment. What did I say about the comment? About using only broadcast. Which means you don't listen. And nobody is writing any notes or comments. That's not how you learn at the university. Because we can't put everything on paper. So when the lecturer is talking, you need to take notes. I made a comment about cats. What are they? Who can tell me what I said? So I'm not surprised that some of you have gotten class 93. I made a comment about using just a plot of cars. What did I say? Yeah, it's gone. Because that one has only 2 variables. Okay, but look at the cars 93. There are so many variables. So if you do it, you get that. No, who has done it? I saw somebody. Yeah, you will get, because it's going to plot each one against the other. Whether they are categorical or whatever, you get that. So please make sure you are still in the book and make notes. Or ask your lecturer. Even if you're giving you slides, the explanation that is being done, you can write it so that you compare it with the slides. And some of you, even the plot that we did, have forgotten about it. Because we did this long ago, at the beginning of the semester, right? Around maybe 4th week thereabout. Graphics in R. So we are just going back, nothing. It's just revision. So if you don't practice and you wait as at now, it will be difficult because now you have exams to write and your attention is divided. This one too needs constant practice. I don't want to see you next year in this class. Okay, so that's it. I'm not going to reproduce it here because it's the same as what is up there. Or you have X, it will just be cars 93, then the dollar sign what? MPG, city. Okay, then the Y will be cars 93, dollar sign what? Price. And of course you get the S label, price in dollars, what have you. And then the S lab, yeah. I said city. But it doesn't really matter whether it is highway, city. I mean, it's basically the same. Okay. So what was your description of that, the relationship between price and miles per gallon in the city? Yes. What is negative relationship? Okay. So we have either negative correlation or negative or positive correlation. No relationship. Okay? So it's a correlation that is negative. So, yeah. So please put in the right words. So there is this sort of negative correlation. And why do we say that is negative correlation? Because as the miles per gallon in the city increases, the capacity of the car, if it is larger, you expect its price to be what? Lower. So if you are going to buy a car and it is, let's say, 4 point something, they are saying that if it consumes more, the price tends to be what? Lower. Of course, in Ghana, nobody wants to buy big engines, especially if you are maybe government sector worker. Okay, let's move on. All right. So please do that if you have not been able to do it. When you go home, do it and make sure that you can describe it. I'll ask you in the exam. Because this one, you've done it in 111 and 223. Okay. Now, next is the correlation. So now, this one, we know that there's a positive correlation. All right? The other one that you did, maybe let me just reproduce it quickly so that we can use it as well. So that is CAS 93. So I start like this. I said it's MPG City. This one will be CAS 93. And price. This will be price. The price is in what? Thousands of dollars, right? Is that the case? Is that the case? So in thousands, right? And then this one is what? MPG. So this is what I said you should do. Basically, that's it. I'm done. Okay. So this is what you expect. So there is a gradual decrease in what? The price as the MPG in city what? Or if a car with a high capacity MPG in the city has a lower price than a car with what? A smaller MPG value. That's it. Okay. Now, so this, I can ask you a question that, let's say if you are a new graduate and you want to buy a car, what is your expectation if you've been recommended to buy a car with smaller MPG? What will be your expectation of the price if you've been advised to buy a car with smaller MPG? The price will be high. Is that okay? Yeah, so basically what the graph shows you is that if you want a car with smaller MPG, the price is higher. Basically, that's it. And this is how you interpret side graphs to or your audience or the reader. Okay, let's move on. So by now, we don't know the actual correlation, the extent of linear relationship between them. So we'll compute the correlation. Remember the correlation, we have what? Pearson's, Spearman, and Kendall. In R, we compute correlation using call. So question mark call. So it computes correlation, it can compute variance, and so forth. All right. Okay. Now, so what is call? We need X and Y, and remember that you have all this. So you see the three correlation coefficients are there. So let's do the immediate one. So please just copy this. We copy this. So this one we know that it should be negative, right? So just copy what we did up, your car's MPG and the price. Use everything, I can take it off. And then the method. So the method by default is to use Pearson's. So if I do this, if I run this, I get the Pearson's correlation coefficient because that's the first one. If I want Kendall, I can just delete everything or I'll just leave it like this because it should take the first one anyway. So I delete the Pearson's, then I get the Kendall. Okay, so we have a problem, and the problem is that no, So, okay, let me just take this one off and see if we still have that. Yeah, okay. So this is a candle. Okay, and if I want Spearman, I have to write Spearman in there. And then I run it. So there are differences between them as is expected. Okay, however, they all give a negative. It's just the extent of the values that will change. Remember that the Pearson will use the actual values of the price and the MPG. Spearman will rank them, right, and use them. Okay. The candle also will be based on ranks as well. Just that the formula for computing them are all different. In the candle, we'll be checking which ones are concordant and which ones are discordant and so forth. Okay. All right. Any question on this? Okay. So when we look at this, remember that in correlation, you have perfect, negative, strong negative, moderate negative, weak, and what? No correlation at all. We can extend this to the other side of the positive side as well. And so this one, if we are using the Spearman, it's approximately 0.6. So yes, no more, a bit moderate relationship between them. In other words, as a car with a higher MPG, we expect it to have what? Lower price, and vice versa. Okay. All right. Any question on this? Yes. Yes. So if you get a correlation, okay. So we have perfect. This is perfect. This is no correlation. Okay. So around let's say up to 0.3, 0.5, let's say 7, thereabout. So around here we can say it's weak. Over here we can say it's moderate. Up to here we can say strong. And then this will be perfect. So yeah, you just use something like that to describe. Okay. Any question? Any question? Okay. So I move on. Now, remember that this is descriptive statistics, right? Which is what we will do in 111. But in 112, you've been taught in 223, you've been taught how to test for hypothesis concerning the correlation coefficient. Is that not it? Yes. How do you do that test? So I may ask you to test the correlation 0 as against, let's say, not equal to 0. We can also test positive. We can also test negative. Is that okay? You've done this, isn't it? You did not do this in 223. Please, did you do this in 223? Yes or no? Yes. Well, what is the test statistic? We've been asking this question in 223. So if you did not do it, learn it on your own. Because I've been setting the questions and I know that we ask questions. So. Just that this year I'm not teaching. Okay. Yeah, but essentially it's a T distribution. Okay. Yeah, and so forth. Okay. So let's see. So how do we do this test? We're going to use what is called core test. Okay, so testing hypothesis on rho, and rho is what the correlation coefficient. Okay, so it's the same as what we did. So we'll use core.test. So it tests for what? Association or correlation between what? Paired samples. For correlation, you actually do paired samples, right? I cannot find correlation and one is the size is 10, the other is 15. It won't be possible. You must have corresponding test. Okay. So how do we use this? Basically, just like what we did, call X and Y, or you can also use a formula if it is done in a way that you have the grouping variable as one column and then your quantitative variable as one column as well. Then you can use the formula. So let's just go with this for now. Right. So what do? It's just we now want to check whether the correlation we are experiencing is actually significant. And remember that you can do two. We can check not equal to, greater than 0, and less than 0. All right. Okay. So we suspect that there's a negative correlation. We can check whether this negative correlation is actually the case. So in that case, I'm going to test this, right? This. So I'll test this as against H1. Rho is less than 0. So our test or our research question is to now check whether there is actually a negative correlation between what? The stopping distance of a car and what? No. What was it? Which one did we do? The price, yes, and the MPG, right? Okay. Whatever we are doing, when you go home, please go through it with the car, the braking distance of a car and the what? It's what? Braking distance and what? Speed, yeah, and so forth. Okay. All right. So let's go back. So this one, the X and Y, we already have it, right? So I'll go up here and copy and paste. Okay, like that. Okay. Then the alternative. From what I have written over there, what should be my alternative? Look at the top one. We are testing this. So what should be the alternative hypothesis? In R. It should be less. Good. You are right. So it's not two-sided. If we were using this, we would have selected two-sided. Is that okay? If it is this, we will select what? Greater. And if it is this, we select what? Less. Okay, so this one is less. So we can delete two-sided and what? And greater. Then we are left with what? Less. Okay. Then the method. We can stick with Pearson or any other one. So this one, I'll leave it like that, which means it will take what? Pearson, because that's what? The first one. Is everybody okay with this? Okay, good. Then the exact, we can delete it, not quite necessary. Confidence level. So here, if in exam, I ask you to do 90%, and then you leave it like this, that would be wrong. So you can change it to 0.9. Okay. Continuity, not necessary, and the rest we can delete it from there. Okay, so this is how our test will look like, and then we conduct it by running it, and then we check the results. Okay, something is wrong. Yeah, because I did not delete that one. Good. Okay. So that's our results. Please hurry up so that I can interpret it. I wanted to leave some time for you to do tutorials, so let me hurry up. Because you have your question after this, you should be able to solve all of them. Please hurry up. So you just copy what you did at the top. I didn't ask you to do that one way back. Yeah. Okay. So do that, and then your alternative will just be less, and then what again? Method, we did not do anything to it. Then you delete the rest and run it. You get the results we are interested. And please look at the way line talks about the data, right? Okay, so it tells you, first of all, it will tell you which type of correlation you computed. In this case, it's what? Yes. So if I ask you to find the Spearman-Cram correlation, and you leave the method as I have done and see Pearson, it will calculate Pearson, not Spearman. Is that okay? So please take note of that. So you get that, then you come to data. So it will reproduce the data you use in computing your correlation. The next line talks about the T. The T is what you have obtained from your 223. Is that okay? Which will just be, if I remember correctly, you have square root of what? N minus 2 something. Is it? And then 1 minus r squared. Yes? Yes. Yes, you delete all of them. Okay. So that's what you obtain from your 223. Okay, the T. And this we can read T degrees of freedom 91. Okay, from table, you can do it now by using QT with your P, in this case 0.95 and the DF is what 91. That will give you a value, and that value you can now compare it with what? The negative 7.07. In this case, what is your rejection rate? We will reject if the T we computed is less than what? Negative T n minus 2, because it's one sided. So we're showing out. Okay. Then we have the p value. What is the p value? Very small. Is that okay? So what is our decision using the p value? We reject the null hypothesis and conclude that. What will be our conclusion? Yes. What will be our conclusion? We have a significant negative correlation between. So whatever you do, you must qualify it in relation to the problem you are dealing with. So first of all, you say that because the p value is small, in other words, smaller than your alpha, we reject the null hypothesis. And that null hypothesis is what? That there is no correlation between them. Okay. And then we are going to conclude that there is a significant negative correlation between the price of the car and the MPG indices. Is everybody okay with it? That's it. We can also move on to talk about the 95% confidence interval is it. So if you look at it, it is between -1. Remember, correlation is between -1 and 1. So it cannot be starting from infinity. So you start from -1, the confidence interval is up to -0.47. So the first thing you do is how do we use the confidence interval to make a decision? Yes. Hello. Yes. How do you use the confidence interval to make a decision? General. Any question? Okay, so let's move on. Now, regression. And you have done regression too. So, linear regression. And we are only doing simple linear regression. So let me add it, simple linear regression. So I'm doing one example. Then I will, there's a video on it. You can watch us all to get more examples. Okay, so what we did now, okay, gave us a relationship. We've seen that there is what? And a significant negative correlation between what? Miles per gallon and what? Price. Okay. So if you finish school and you want to buy a car, and they show you that, okay, or they tell you that this car, the miles per gallon is 27. Now, can you tell us what the price will be from this graph? If you look at it, there may not be any point on the 27th, x is equal to 27, which is somewhere here, where the cursor is. Please, are you following? Okay, some are still busy on their laptop. It is important you follow this. Okay. Now, so here, 27, I'll not touch anything, it's empty. Okay, so correlation does not give us the, or it doesn't have the ability to do prediction. Or it will tell us that we expect that as this increases, this should increase, or as this increases, this should or decrease. If we want to be able to predict, so for example, I want to be sure what is the average price of a car that is, let's say, that has 20 mpg. Then in that case, I need a linear regression, which will give me a formula for a line that can be drawn within this. Then I can use it to do prediction. So that's where we move from correlation to what? Regression. Okay, so they are related. Now, how do we perform regression in R? Well, we use LM. So let's look at the question mark LM. So LM fits what? Linear models. Okay. And the usage is this. So I'm going to show you how this is done. So we copy up to that. And this. So we need a name for it. So maybe fit LM. Then the data we are going to use is CAS93. Then the formula, we've been using this previously, right? What will be the formula? It's price on what? Miles per gallon city. But I need to get the exact way the price is spelled and also the way the variable miles per gallon mpg is stored. So one way to do this is that you go to the file. It's price. I can go up here and copy. So once I bring in the data, then I don't need to, how should I put it? I don't need to repeat CAS93 because I've already provided the data. Right. So data is, and then price. So you put tilde in there, and then we run this. Okay. So your model is now done. There was no error, so we have that. And then you can use summary to get the results displayed. So let's all do this and get a summary, and then please you pay attention as I try to explain what is. So that's a simple linear regression. Okay. Please, are you done? Have you gotten your results? Yes or no? Good. My dear friends. Hurry up, hurry up, hurry up, hurry up. Please, this is for the letter. What are the letters? Who else? Please, let us know. No, I think I explained you. Who else? Who else needs help? Please, if you need help, you will raise up your hand. We want all of you to have your result, then we can interpret it. So, okay, so we can move on. I think nobody is raising their hand. So, look at your result. The first one, so I'm going to relate it to what you do in 223. I'm sure not. Okay, so the first one gives you the call, the formula you use, then the residuals. What were the residuals from a regression? What are the properties? If you fit a regression model, the residuals you have, what will be the average of the residuals? Hey, my dear friends. It should be 2, 2, 3. You fit a regression model, your residual should sum to or you only copy the formula. The formula, you know it from SHS. Y is equal to MS plus C, right? Here, what you need to know is how do you compute it? Remember in SHS you were just using change in Y over change in X because you have 2 points. Here you have several points. Okay? You are not just taking only 2 points. So if you look over here, there are several points within this. You want to be able to take everything into account. So what do? One method is through the least squares criterion. And what is the criteria if you are using the least squares method? Yes. What is the least squares method? What is the criteria? Or how do you find the least squares estimate? Okay. All right. Nobody is talking. Let's move on. It's 223. This is 240. Okay. So, we move on. So let me just explain because you've done it in 223 and because you don't want to talk. I assume that you know. And then we can move on. I'm sure they did not just put the formula there for you. You must have gone through the process. That you want a line that will pass through the middle part of what? The point. That's the idea. And how can you find that line? It means that the distances between them, both below and above, should be equal. such that when you add them, because you are subtracting to get the residual, some will be positive, some will be negative, because it is at the central part. If you sum them, the negatives will cancel the positives and you get 0. So as a matter of fact, the residual should be 0. But that's not the case all the time, because if you have this, you have a scatter plot like this. You want a line that will pass through the middle part. So like that. Okay. So the difference between this is the actual point. It is maybe 100, but the line says it is what? 70. So the difference between here is the residual. So in the least squares criteria, you are minimizing what? The residual. But because the sum of the residuals will get you 0, in statistics, what do we do? To get around this, you square. Okay? So to get the difference between this line, you see this one line, the residual is what? What will be the residual for this? Oh, you don't know what residual is. I just explained. There's a difference between the actual value and what the line is telling you it is. So this one, what is the residuals? If these are the actual values. I don't believe that your lecturers did not tell you about residuals. It can be. Because I've been teaching this course for more than 10 years. So so whatever it is, if you were doing it like we were doing in XS, SHS, it's completely different from here. Please take your time and understand the principles. Other than that, you will be memorizing formulas. Because if you forget the formula, you should be able to go through this to derive it quite easily. Because you know what differentiation is. You set up, so this one, the residuals will be 0 because all the points are on the line. Over here too, even though they are not on the line, if I find the residual, it will also be 0. So when I say residual is 0, there's ambiguity. You cannot tell me whether it is this or that one. Okay, but if I square, this one is 0 squared, 0 squared, I'll still get 0. This one, I'll get a positive number because the negative will still be squared. So once we square it, we get the, we are now able to differentiate between this case and that case. It's the same thing as using variance, okay, and standard deviation. Why do we have to go through variance to square before we now find standard deviation? Can't we just find the difference? But if you find the difference between the mean and the actual values, and you sum, you get 0. So please take your time and understand whatever you are doing from basic principles, so that you avoid memorizing problems. Okay, let's move on. Okay, so over here, why am I struggling or worrying myself with that? Okay, so we expect, for example, the median to be 0 because we want a normal distribution. Standard normal, but it's not 0, which means it's what? It differs from 0. We can find the mean and so forth, but this gives just the quartile. If it is symmetric as well, then I expect the maximum, because it should be standard normal, I expect the maximum value to be the same in magnitudes as the minimum, because the minimum will be negative, the maximum should be what? Positive. Because of the way we do this, right? Some are down, some are up. If they are symmetric around the curve, the line, then what is down, the magnitude of it should be the same as what? The magnitude up there. That's the sort of thing you look out for. But look at the maximum. The maximum is 38. The minimum is what? Negative. It's way different. So that gives you that the normality in there may be suspect. Okay, let's move on. Then the coefficients. Remember that in 223, you talked about y. So you have a model y is equal to beta naught plus beta 1x plus epsilon, right? This is a random model because this one, we assume that it comes from a normal with mean 0 and variance or sigma squared. So because this is random, this is deterministic, okay, so if I add deterministic value to a random value, what do I get? The result will be random. Is that okay? Which means y is also random. So this is why we say this one is what? Independent variable. Okay, the independent variable you know already. So I know that if I'm going to buy a car and I go to the showroom, they will tell me the MPG straight away. Because it comes from the manufacturer's so it's known already. What we don't know is the price. Because the price maybe they are selling at Medina will be different from that at Circle. And so, okay? All right. So, together with this, we get this to be random. That is why we can put a distribution on this. So, what is the distribution of y? If it is deriving its distribution from this. Of course, you find expectation, right? What is the expectation of y? It will be the expectation of the constant value is what? The constant. What is the expected value here? You've done 221. What's the expected value here? It is what? 0. So what is the expectation of y? No, not 0. It's this one. Beta naught plus beta 1x. Is that okay? What about the variance? We find the variance of y. This will be variance of a constant plus the variance of a random variable, right? What is the variance of the constant? Some are not even looking here. Okay, so I get passionate about this because if you don't understand this, then the course becomes difficult for you. Okay? Whatever you are learning, you have to take a step back and understand it from basic principles. So you just go to 223, we just give you beta naught is y, what is it, y bar minus beta 1, then that's all. You don't understand it at all. You have to know it from basic principles so that you can derive it on your own. Okay? And so that's why we say take a book and read. Yeah, to explain all this we are talking about, but we ask you a question, nobody answers, so you don't know whether they understand it or what, and it's difficult because you don't know whether to move on or go back. Yeah, previously, when I'm teaching, I know that I've taught you. Now I'm not the one teaching because when I'm teaching you 223, I'll go through all this. We will derive all this. Okay, this you've done it in 112. So if you have, and you've even done 221 now, this semester, so you are way even above this. So when we are asking you this question, you cannot tell us that you don't know, unless you are not attending class. And if you are not attending, you are not writing the exam. Okay? If you have not attended for 75%, you can't write the exam. Okay, so we find the variance. This is a constant, so what is the variance of the constant? 0. What is the variance over here? What is the variance for this random variable? For the normal distribution? It's variance of, this is the random variable. This distribution is normal with mean, 0, and variance sigma squared. I'm asking you, what is the variance? Sigma squared. Okay. So the variance is what? Also sigma squared. So you see, we know the distribution of y as well. That's why I said y is what? Random. So what is the distribution of y? Well, the distribution of y is also normal with mean beta naught plus beta 1 x plus, and then sigma squared. So in 333, next, when you come back in level 300, you will be doing 333. You will be finding the same least squares you did from the maximum likelihood principle. And that will use this, what we are talking about now. So even though we are not examining you as you move up, you need all the things you've learned. That's why I said 1, 1, 1, 1, 1, 2, 2, 2, 3. You can't leave them behind. Make sure you are going after exam, take your time, take a book and read and make sure you understand. Otherwise, your life here will be miserable. Because at a point you can't graduate and it's not pleasant at all. Okay, so that's it, and it's the same principle you use in doing this. So if I know beta not beta 1, then I know the deterministic part. Okay, so your y, this is random. But because we can find beta naught and beta 1, we can now find y cap is equal to beta naught cap plus beta 1 cap x. So this one is not random. Because we know is that only the deterministic part, right? Okay. So what we are doing is to find beta naught and beta 1. That's what you are doing in 2, 2, 3 as, yes. Yes. Yeah, X is not random. Yeah, at the higher level, you can have a regression in which your independent variables follow a distribution. But at the lower level, we assume that it's constant. That's what I'm saying. That, for example, let's say you are a community nurse. You go around to give polio injection and so forth. You may not be able to carry a weighing machine with you. Okay, so in Ghana, we may have done a study to study the relationship between weight and age. It may give us some approximate way of estimating weight. So if I don't have the machine, of course, I can ask the parent, what is the age of this child? They tell me 4 years. Then I can easily put it within my regression model and say that the child will be around maybe 8 kg or 10 kg. So I can now decide what dosage to give the person. That's the principle behind it. And whatever you are doing, as I said, get the practical aspect so that it makes it easier for you. Even if you are encountering problems, you know that this one is useful to you. Otherwise, everything you are doing becomes abstract and you have no interest in it. Okay? The interest is what is going to help you to sustain yourself here. It's not an easy course if you do statistics around this and click. Okay? Yeah, but you don't give up. That's how life is. The fact that it's difficult does not mean you give up. Okay. All right. So once we get this, we know the regression. Then the question that I was asking comes in. If I know this and that, then if I know X, I can easily tell what is the average Y. Is that okay? That's the end product of, or the aim of regression, that we can get a model, and that model can now be used to predict. So now if I put in 25, X is equal to 25 because I know I can tell you the price of the car. Okay, so from our label, this is what we have. So our Y, and here Y cap is what? The price of the car is 42.36 or 7 minus 1.02x. So this is our model, which relates the price of a car to a what? The MPG. Is everybody okay with it? So these are the estimates of the coefficient. Beta naught is this, beta 1 is that one. The intercept, you remember from your SHS, y is equal to ms plus c is the same thing. C is the intercept, that's it. Okay, so now we go to your 223. How do you interpret it? I'll ask you as well in your exam. So, as I said, that's the beauty of university education. The one teaching you is the same person that will set the question and mark it. So it's not like that somebody will say somewhere. Whether you have completed the syllabus or not, you will set it. Okay. So now, how do we interpret this? So the first one is when x is 0. In some cases, it doesn't make sense. Because you don't have x to be equal to 0. In this case, you cannot make a car in which the mass per gallon is 0. It means there will be no fuel, right? Consumption. Maybe it's a little bit in space. You think that it needs fuel to move around. Is that okay? Yeah. So in this case, it doesn't really make sense. Or scientifically, it's not natural. In fact, it's not natural. Or scientifically, it's not something you can obtain. So what it says is that if a car has no miles per gallon in the city, its price will be what? 42, approximately 42,000. Is everybody okay with it? Okay. So I said that's how we interpret the 42. If there is no, the miles per gallon is 0. In other words, if the car is traveling within the city, it doesn't consume any fuel, then its price will be around 42. Yes, no, but it's 0. If it's 0, that part will be 0. I'm coming to the next one. So is everybody okay with the constant? The intercept, how to interpret it? You will get the intercept, the y will be equal to the intercept if x is 0, isn't it? So that's how you look at it. Okay. The next one is the coefficient. How do we interpret this? You must have done this in 2, 2, 3 as well. If you have not, they will ask you. Okay. If they don't ask you, I will read the questions. Okay. Now, we have negative 1.02. If you remember, the correlation was negative, right? It's the same thing. So if the correlation is negative, the sign of the beta 1 will also be negative. And this one will also ask in your exam. Such a 2 user. Okay. Yeah. Because as x increases, we are expecting y to decrease. So there should be that negative relation. Okay. So how do we interpret this? Well, if we move x by 1 unit, it means the y will decrease on average by 1.02 units. But now I must include the units from back and I'm checking whether you are speaking in relation to the problem we are dealing with. So if you look on the board, mass per gallon, it's in what? Check. Your question mark, how was it measured? I think it's the same miles per gallon, right? So it means that if the miles per gallon increases by 1, you expect the price of the car to decrease by 1.02. And in this case, it means $1,020. Because the price is measured in whatever value you have there in your 1,000. Is that okay? Yeah. So 1.02, if you multiply it by 1,000, you get what? 1020. So it means that if you increase if they are doing the production and they increase the engine capacity in terms of the mass per gallon by 1 unit, you expect the price of the car to increase by over 1,000 to the 1,020 dollars. Is everybody okay with it? So that's how you interpret this. And this is crucial for you in this course as well as in your tutor. So please, when you go home, the stopping distance, go through all the exercises you have done and make sure that you can interpret them as well. Next is prediction. No, let me go on. Now, in 223, we can also ask you to test whether these, in other words, you test whether this one, is this relation significant? Okay. In that case, I'll have to test the hypothesis whether beta 1 is equal to 0 against beta 1 not equal to 0. If beta 1 is 0, then y does not depend on x, right? It is just some random constant plus or some random value. So we can do a lack of fit test. Okay, or test overall regression. If it's overall regression, we are testing whether the whole thing is significant. That's where you use the ANOVA table as well in 223. So you divide your sum of square total into sum of square regression and sum of square what? Receiver. Or sum of square error. And then you create an ANOVA table, just like we did in the ANOVA table case. Okay, we can do so here as well. If you look straight ahead, so here, should we include intercept? In other words, is beta not equal to 0? Well, the p-value is very small, so what do? You reject H0, which means that 42 points so should be maintained. It's actually significant. Is everybody okay with this? Good, okay. Next is whether beta 1 should be excluded. If beta 1 is 0, then it means beta 1 times x is 0. It doesn't play any part in the model. Well, the p-value is also small, so what do? What do? We reject the null hypothesis and conclude that the beta 1 is not equal to 0. Okay, so it means it should be maintained. Okay. Another way around is what you did in 223, which is the ANOVA table. That is what you see over here as F. So it's 4.49.76. Remember that as you reject if F is greater than what you read from tables. What can we read from table? It's F with 1 and 91. I can do so now. KOF, that will be quite a small value, 0.95. DF1 will be what? 1. And then DF2 will be what? DF2 will be 91. That gives us 3.96. So you see this F from our ANOVA table is way greater than what we read from table. So what do? You reject the null hypothesis, which means the regression is actually what? Significant. Like that. Okay. So that's it with this. Last one is R squared. You remember you've also done R squared. So R squared gives you what? The percentage of the variation in the dependent variable. That is what? Explained by the regression that we have done. So if you take the price of a car, if we plot the price of a car on its own, we'll have a scatter plot. So variation between them. So that variation we are experiencing, okay, the miles per gallon in the city explains only what? 35%. Which means the other 65% is not what? It's unexplained. In other words, it's caused by other variables other than what? The miles per gallon in city. So basically, that's it on this regression. You can also predict, as I said. So the prediction, remember I said 20, so 27, right? There's nothing there to show us, but we can do it over here. So actually, if you want to, so y cap would then be equal to 42.37 minus 1.02 times what? 27, right? So if you have your calculator and you compute this, the y cap will be the expected price. In other words, the average price of a car with what? 27 miles per gallon. Is that okay? And now we can do so by using predict. So you can do question mark predict. And then you get your new data. Your new data should be a data frame containing miles per gallon equals 27. So please do that as well using predict. So that, what's the time? Yes, I have some few minutes to talk about the last one. I'll make the video available to you. There's another video online on this same thing. Please make sure you watch so that we you understand whatever we did here. Now, any question? Any question on this? Okay, so we understand, isn't it? Can I move on? Can I? Oh, my people don't want to talk to me today. Okay. What else do I want to talk about? Chi-square test. You've done this in 223 as well, right? Isn't it? Oh, this one is equal to summation observed minus what? Expected divided by what? We square it and then we divide by what? Expected. EIJ, right? So it means if I use this one, I must have a J and I, right? Like that. So you do this, right? What do you, then you compare this with what? Of course, your rejection. Critical reading is this. If it is chi-squared, maybe R minus 1 or C minus 1, whichever one. R or C minus 1 times what? R minus 1. Is that not what you were doing? And then maybe some alpha, right? Something like that. Okay. So what is this test? When we have a contingency table, it helps us to check whether there is a dependent. In 223, you actually do the independence and the goodness of it. Okay? I don't have my time, so I'll just do the independence. What is it? Well, in some cases, remember that we have correlation. That is for quantitative variables. But what if I have quantitative variables, but I need to check the relationship between them? Then I can use the chi-square. So the chi-square test is like the counterpart of what? The correlation in the case of what? When we have what? Categorical variables. Is everybody okay with it? Okay, good. Now let's go to, there's a data set called survey. Let's quickly look at it. Survey. So chi-square test. And this one is just a independent chi-square test, right? We cannot so do the goodness of it. Okay, so let's look at the question mark for survey. Okay, or we should still use the CAS 93. Okay, let's use the CAS 93. Survey, CAS 93. Okay, the survey, it's okay. Survey. Right. So this is a student survey data. It's a data it contains responses of 237 statistics students. Statistics 1 student from University of Adelaide to a number of questions. Right. So they were just like you. It talks about the sex, the span. So if you look at the span, sex is categorical, right? Span is not categorical. It's quantitative. Span of non-writing hand. Okay. W hand is the writing hand of student. That is also categorical. You either write with left or what? Right. Okay. You cannot be writing with both right and left at the same time. Fold. Well, if they ask you to fold your arms, which is on top? So in some cases, some people will fold their arms like this. So in this case, left is on top. This case, right is on top. If I do this, neither is on top, right? Okay, so they are right on left, left on right, and then neither, which is like that. Okay. Is everybody okay with this? Yeah. So we may want to check whether the way we fold our hands is related to our sex. So in other words, do females, if we ask, let's say, females to fold their arms, are they all going to do this? Or they are all going to do, or they will do something like that. Do you get what I'm saying? So this is a situation where a chi-square test can be used. So we are checking for dependency. That's your gender, or in this case sex, influences the way what you fold your arm. Okay, please, are you with me? Okay, so let's do that. Remember that to do this, we first need to create a contingency table. If you remember, we've done this earlier when we were doing what descriptive statistics will you use before we go on to do this test? What graphical display can you use? Bar plots, which of them? Because we did this. It's the component bar graphs, right? Those stack bar graphs. Okay, we'll do that before we move on. So let's say we call it F tab, so frequency table. So we'll use table, and then we call survey sex, and then survey again. We've done this earlier in the semester. Right hand. Is it W hand or is this one W hand? Okay. So we run this, and there it is. Okay. So left, female, only 7 of them you fold their hands like this, right? With the left on top. Okay. 110 of them folded their hands like this. Okay. For male, it's like that. So if you look at it, most of the students will fold their hands with what? The right on top. Is that okay? Yeah, so if you have to comment on this, that's how you look at it. Okay. And we can say that, what else? I think there are, okay, the males are more than what? The females, right? So that's also another observation. Is that okay? Yeah, by just one. Because when we sum the female-male rows, we get 117 and what? 118. Okay. All right. Remember that we can also use box plot. Oh, sorry. Bar plot. Okay. So bar plot for this, if you remember, then we get something like that and left. So if you remember, we did legends, right? We colored them and then we had legends. You remember all that? Please make sure you can do this before the exam. Okay. Lastly, what I want to talk about is the chi-square, right? So what do we do? So the chi-square, there is chi-square test like this. So it calculates on the Pearson's chi-square test for count data. You can actually do it like X and Y. Yeah, but X can also be a matrix and so forth. So I can just put in it chi-square test, and I put my F table, which is a matrix. There it is. Okay. So this is a test you've done in 223. After the chi-square value is very small, degrees of freedom is 1. How can you explain this? Why is the degrees of freedom 1? Because, please speak up. Why is the degrees of freedom 1? You were saying it, yes. There's only 2 variables. Are you sure that's the explanation? Yes. Who can help us? Yes, there's two variables, but that's not really the case. Yes. In 223, you would have computed this yourself. The thing is even on the board. The degrees of freedom is all. The number of rows minus 1 times all. The number of columns minus 1. How many rows do we have here? 2. How many columns? So 1 times 1, we get what? Is that okay? Please, are you okay with it? If you check this one, this 2 by 2, so we'll get 1. Okay? All right. So let's see. So here we can use the p-value. What do we do? Should we reject? Remember, the critical region is rejected for a chi-squared is greater than that one. But this chi-square value is very small, so we will not reject it. Which means yes, 223. You did 223. I wasn't there. What is the H naught? That there's no relationship, right? And H1 is all. There is relationship. Is that okay? So here, we fail to reject the null hypothesis, which means what? There is no relationship between what? The sex and what? The is it right hand or which hand is on top? Something like that. Okay. So that's it. Any question? Otherwise, we are right on time, except that we couldn't have your tutorials. So you must fix a date and have tutorials. Now you should be able to solve all the problems on the question I gave you. If you're unable to, then you have a problem, which we must solve before March. Is it March? Yes. Marching. But you must tell me when you can have your eye. Tomorrow. Saturday. Sunday. Oh, I should put 000 there. That one too. No. Okay. So let's do some practice on Sunday. Hey, would UGCS people come on Sunday? I have to find out. So I'll put it on your platform. Sunday, 3:30. Is that okay? By that time, you would have gone to church and prayed so that God will intervene. Or 3 p.m. Why? As for this university, we do not have, there's nothing about religion. We don't want anybody to take us to court. So whether Friday or Saturday or your shrine day, we are writing exams. Okay.